Grade 12 learners, welcome to today's mathematics lesson. This lesson is brought to you by Gauteng Department of Education in collaboration with Cyberno Discovery Center. My name is Analytical. Our topic for today is paper 2 revision, and we are going to focus mostly on trigonometry, but we are going to go through all the 4 topics of paper 2, and we will just run through the concepts that we will have to look at before we write our paper 2. We will do more activities that are based on trigonometry today. I hope you wrote well for your paper 1. It's water under the bridge. Don't think much about it. Let us focus our attention on our paper 2. Please have your calculator and somewhere to write, because I would love to engage you and you have to be doing the activities with me as we move along. Now, our paper 2 topics, we have statistics, we have analytical geometry as well as trigonometry and Euclidean geometry. I hope you are aware of the weighting. Previously, our Euclidean geometry had more marks than trigonometry, but now for our paper, trigonometry has 50 marks and Euclidean geometry has 40 marks. These 2 topics contribute about 90 marks of paper 2, and Euclidean geometry has the same marks as analytical geometry. Statistics, we have our 20 plus minus 3 marks there. Now, our minimum target, in order for us to get 45%, but I know no one is aiming to get 45%. We all are aiming to get very good marks. Now, we should get for question 1 and 2, which is our statistics normally, we should get about 12 marks. For analytical geometry, we should get about 15 marks. Trigonometry, we should get about 20 marks, and Euclidean geometry, we should get about 10 marks. I know we are going to get more than that. Now, if we are aiming for a bachelor pass, we should get at least 100 marks in all the 4 questions. And for us to get a distinction, we should get 120 marks out of 150 for us to get a distinction, and I know it's possible. It's only 4 topics. Now, I will not talk about the weighting of the questions that was discussed yesterday. The same weighting of the questions is the same for our paper 2. I'll just go through our information sheet. You know that for our statistics, these are the formula that we normally use. For our analytical geometry, that is our formula that we normally use. And for our trigonometry areas and the application of trigonometry, we are going to use those at the bottom. And we know for our reductions, cast, we normally use that page. Now, I would want us to look at statistics, the things that we have to go through in order for us to prepare for our statistics paper. We should be able to look at our measures of central tendency for grouped and ungrouped data, our mean, mode, and median. We should remember how to calculate and get those. We should be able to look at our measures of dispersion. That will include our range, our quartiles, our interquartile range, and we should know how to calculate those. Sometimes we are asked to use percentiles, and we use quartiles as well. The 5-number summary on our box and whisker plots. We know that we should get our minimum, our maximum, and our Q1, Q2, and Q3, that is our upper quartile, our median, as well as our lower quartile. We have to interpret our box and whisker plots, and we are aware of how we get our summary for the interpretation of our box and whisker plot. We are aware that for us to say our box and whisker plot is symmetrical, we know that our x bar must be equal to our q2. And then we also know that if our x bar, which is our mean, is greater than our q2, we say our box and whisker plot is skewed to the right, or it's positively skewed. And if our mean is less than our q2, we say our box and whisker plot is negatively skewed, or we say it's skewed to the left. Now, we also have to know how to calculate our estimated mean for our grouped data. We are also able to calculate our standard deviation for our ungrouped data and for our grouped data as well using a calculator. And we should also be able to interpret the meaning of those. We are also going to look at the model class, and we should also be able to look at how we get our median for our grouped data there. Now we should calculate our variance. The formula for our variance, we have it on our formula page, and we know that standard deviation is the square root of the variance. So if you have standard deviation, you're able to get variance. If you have variance, you should be able to get your standard deviation as well. Now we should be able to interpret our ogives, which is our cumulative frequency curves, and we should be able to plot them as well. We should be able to identify our outliers, and remember, how do we do that? We know that our outliers should be anything that is outside the interval Q1 minus 3 over 2 of our interquartile range, or Q3 plus 3 over 2 of our interquartile range. Remember, some of the literature that we have, they use 1,5 IQR, which is the same. I've just chose to use the fractions there. We should be able to use this to identify our outliers. Anything that lies outside this interval becomes an outlier. And we should also be able to use our statistical summaries to analyze and make meaningful comments. Please, we need to give answers that make sense when we are looking at some of these questions. I've given one example where we are going to make comments and use what we have discovered to help us comment there. Now, for our grade 12 statistics, we have scatter plots. We should be able to draw our scatter plot. We should also be able to draw the line of best fit, which is called our regression line. And we should be able to interpret the meaning of that line of best fit, and we use it to extrapolate and interpolate where we are supposed to estimate or calculate. If given one of the values, we use our equation to help us get what we are supposed to get there. We should also use our correlation to analyze and make meaningful comments. And we should also use our statistical summaries to predict and to associate our bivariate data and as well as our least squares regression equation. Again, calculator use is very important. Please make sure that you use a calculator that you are familiar with to avoid making mistakes and losing marks unnecessarily so. Now, we said our statistics formula for our mean, we know that we use that summation. It is the sum of all data items divided by the number of data items. Our variance is given by the sum of the difference between our data items and the mean, and we square that. We sum it up and then we divide that by the number of data items. It will give us our variance, and the square root of the variance will give us our standard deviation, but we can easily use our calculators there. For our regression analysis, the least squares equation, regression equation, is given by y is equal to a plus b x. Our job is to find the values of a and b, and then we use them accordingly. Also, sometimes we are supposed to comment and calculate our correlation. We use our correlation coefficient we get from our calculators, which is our R. And then when we make a comment, please make sure that you comment with the terms that are in the middle there. If our R is between 0 and 0.25, we normally say there's no correlation. If our R is between 0.25 and 0.5, we say it's a very weak association or correlation. 0.5 to 0.75, it's a moderate association. Now, please, when we say moderate, it either has to be moderate positive or moderate negative. So that those two terms must go together for you to get the 1 mark on the comment. Because if you just write moderate without mentioning whether it's a positive or a negative correlation or association, you will not be awarded a mark. They have to go together. Between 0.75 and 0.9, we say it's a strong. But please note that different literature have different scales for this commenting and the association of our strength there. So if you have read a different one, you can still use it, because when we mark, we look for the key terms. We look for the key terms. Others will have vary, others will not have vary, so we should not worry much about those. But between 0.9 and 0 and 1, we say it's a very strong correlation. It's either going to be positive or negative. As you can see, I have included the positive and the negative part on the other side. When our R is equal to 1, then it's a perfect correlation, or sometimes the other term that is used, it's an association there. Now, I will give you 5 minutes. I know you are from an exam, but I don't want you to sleep, so I want you to do something now. I want you to just quickly answer that question, practice your calculator work so that we check if it's on point. I will give you 5 minutes to just practice our statistics now. Welcome back. I hope you are able to quickly punch in the data using your calculators, because I don't want you to sleep. I know it's warm outside, so I want you to move with me. Now, what did we get as our mean? We are going to be using our calculators. Others are using different calculators, but we know that we have to go to our statistics mode, and then we punch in our data, we save our data, then we shift, and then we go, depending on the calculator that you are using, you are able to get your mean. Our mean is given by the x bar, and we know that to get the mean, we are saying the sum of all data items, 26 plus until the last data item plus 40 over the number of our data items, which is 15, and then we'll get we got our mean as 25 megabytes. Now, so you can get your 2 marks there, or if you have shown that step, you'll get a mark for the sum and then the mark for the mean. And then we move on to standard deviation. Again, we are using our calculator. We should have gotten our standard deviation as 17.65. It's only 1 mark. Answer only, we get our 1 mark. Determine the number of days in which the amount of data used was greater than 1 standard deviation to the mean. So, to answer this one, remember, we looked at, just as a reminder, x bar plus 1 standard deviation. So we want those that are above, so we are going to substitute to get the interval. The interval that I'm going to use is for within, so that we are able to discuss the other versions of this question that can come. So we will have our mean, which is 25, minus our standard deviation, which is 17.65, and then the upper limit becomes 25 plus 17.65. And for our interval, we will get our 25 minus 17.65. You quickly do that. 25 minus 17.65, and that should give us our answer is 7.35, and the upper limit we will get 42.65. So, because the question says above, you are only looking at the data items that are greater than the upper limit of 42.65, and that should give us our answer as 2 days. So we are looking at those that are greater than that. So that is that 69 as well as that 58. There are only 2 of them. 2. And then if they said within, you are going to count all those data items that fall between 7.35 and 42.65. If they had said below, you are supposed to look at those that are less than the minimum in the interval after you have subtracted and added our 1 standard deviation to the mean. When they say within 2 standard deviation, it means whatever we got as our standard deviation, our formula will be given as x bar minus 2 standard deviation to get the interval x bar plus 2 standard deviation. It will depend on the questions that we are asked, and we should practice this so that we know how do you determine within, outside, above, and below. Those are the kind of questions that can be asked on this question. Now, also looking at that data that we have used, sometimes we'll be asked to give them data like that, and you're supposed to find the 5-number summary, and then you come up with a box and whisker plot. you should remember that for you to do our 5-number summary, we need to first of all arrange our data items in ascending order so that we are able to determine our Q1, our Q2, our Q3, our minimum and maximum. From there, we are able to plot our box and whisker plot. But the most important thing is that our data has to be arranged first, because in this case, it's not arranged. Now, let's move on to 1.3. The maximum total amount of data that Sam must use for the remainder of the month if she wishes for the overall mean of April to be 80% of the mean for the first 15 days. That is where we start losing marks, because we do not read the whole sentence. Now, keywords there. 80% of the mean for the first 15 days. What the mean for the first 15 days? We got it as 25 megabytes. So, for us to get 80% of the mean, you will have to find 80% of 80%, we know it's 80 over 100 times our mean, which is 25 megabytes. 80% of 25, we should get 20 megabytes is the new mean. But let's call the total that has to be used for the remaining days, we will call it X, and then we should be able to get the mean, because now our number of days is 30. The mean, the data that is used for the remaining days, we shall call it X, and the number of days, the first 15, the remainder 15, April has 30 days, so we are going to divide by the total number of days, which is 30, and we get our total is 225 megabytes. So that's how we should answer that question. So the first part is to make sure that you read and understand it. You must get that 20 megabytes as your new mean. How do you calculate a mean? It is the sum of all data items divided by the total number. Our total number of days now is 30 days, and then we are able to get our answer as such. Now, we have another question, which is our regression analysis. This one I will give you 4 minutes just to practice. 4 minutes. I want you to answer those questions in 4 minutes. Welcome back. Now, we know that on our calculators, we are now doing two variable statistic. That is the first thing that you must do when you punch in your data into your calculator. And I'll encourage you, the moment you type in your data, just make sure that you write everything that might be asked before you even look at the questions. Get your A. We got our A as 29.35. We got our B as negative 0.46. And our equation was that. So we would mark our A, our B, then we mark our equation. So we get our 3 marks there. So to predict the temperature, we shall use our equation where we have our speed is 9 kilometers per hour. That is our x. So we will substitute into the regression equation, and then we should get our temperature as 25.21 degrees Celsius. We get our 2 marks, substitution and answer. Also, answer only will get full marks. Now, the other version of this question, they'll give you this information and you're asked to draw a scatter plot. Please make sure that you draw accurately. Your points have to be in the correct positions. And sometimes you're asked to draw a line of best fit. So to draw a line of best fit, we know that it shall pass through our y-intercept. To get our y-intercept, we let our x to be 0. And then we should also get the mean for our x values, which is our x bar, and the mean for our y values. This point must be indicated on our scatter plot if we are doing the scatter plot. And you have 2 points in your graph. You take a ruler, you join the 2 points, then your line of best fit will be correct. 1.23. Interpret the value of B in the context of the data. That is where we also lose marks. You can't say B is the coefficient of X. You are not interpreting, you are just telling us what we know. Interpret. What is the significance of that B? What is the effect of that B in that particular equation? If you check, that B is negative, and you know that if you multiply a negative, a bigger value, the negative becomes bigger, isn't it? So it means if the wind speed increases, the temperature will also decrease. And that is what is the interpretation of the value of that B. Sometimes this question can be asked as, can this trend continue indefinitely? And you'll find sometimes it will be 2 marks. Justify your answer. Others will just say yes, others will just say no. And then on the justification, people will not give reasons. If I give you that question now, can this trend continue indefinitely, and you justify your answer, what would you say as a candidate facing this question in an exam? Can the wind speed increase indefinitely? Can the temperature continue to decrease indefinitely? Because those are the things that you should look at. Is it possible that the wind speed can increase indefinitely? Is it possible that the temperature can decrease indefinitely? What will be the effect on us who are on this earth, who are in that particular time? Can we survive wind speeds of 49 kilometers per hour? Does the environment allow that to happen? So, those are the kind of questions that you will meet in an exam. Please, when you are answering such questions, you should be able to give reasons in the context. Do not just say yes, no, because it is an increasing. When X increases, the other increase, or when this increase, that you are just describing the trend. You are not justifying the answer there. So we should give reasons that make sense. For example, I'll say the trend cannot continue indefinitely, because as humans and as the inhabitants of this earth, if the wind speed continue to increase, wind speeds of 50 kilometers per hour, we cannot survive that. Nothing can survive that. Even the trees will be uprooted. So it's not possible for the trend to continue indefinitely, because also if the temperature continue to decrease, you can imagine when it's now 50 degrees, 50 kilometers per hour the wind speed, the temperature will be minus something. Can we adapt and survive in those conditions? We can't. So that is why those are the kind of reasons that you are going to use. Use your geography, use your life sciences reasons, because those are the ones that you should give. You cannot just use yes, no there. We move on now. Analytical geometry, we are going to be using solving problems that involve the formula for distance between 2 points A and B. If A has coordinates -2 and 6 and B has coordinates 13 and 12, we should be able to find the distance between A and B. We should be able to calculate the gradient there. We should also be able to identify if lines are parallel, and we are going to be using the properties. If two lines are parallel to each other, we know that the gradient of line 1 should be equal to the gradient of line 2. These are parallel lines. If two lines are perpendicular to each other, we know that the product of the gradient of line 1 multiplied by the gradient of line 2, this should give us -1. Then we know that the lines are perpendicular to each other, and we should be able to identify. How do you identify parallel lines in shape? There will always be an indication. Either we use those arrows, the two lines are parallel, or we have double-headed arrows there to show that the lines are parallel. And if they are perpendicular to each other, either on the diagram you are told that the angle is 90 degrees, or you will have a shape like that to show perpendicular. Now, we should be able to derive the equation between 2 points. We know that the equation of a straight line is given by y is equal to mx plus c, or we use y1 minus y2 is equal to mx minus it's y minus y1 is equal to x minus our x1. We just need one coordinate of a point, then we are able to get our equation of a straight line. Now, sometimes you will find examiners want to check whether we are able to. They will give us the equation of a line as ax plus by plus c is equal to 0. We have to be able to move in between this form, our y is equal to mx plus c, and that form where we have our ax plus by plus c. Changing the subject of the formula, we should be able to do that so that we are able to get our gradient and we are able to get our y-intercept. Now, we should be able to get our angle of inclination. We know that for us, if we are given the gradient, to get the angle of inclination, we use our m is equal to tan theta. We get our angle there. And then if we are given the angle, we can deduce the gradient as well. Now, our angle of inclination can either be acute between 0 and 90, or it can be obtuse above 90 but less than 180 degrees. Please, you cannot have an angle of inclination which is more than 180 degrees. Or we cannot have an angle of inclination which is negative. Remember, it is always the angle between our line and the positive x-axis there. Now, The equation of a circle, we know that the equation of our circle is given by x minus a all squared plus our y minus b all squared is equal to our r squared. If our center is at the origin, our equation is given by x squared plus y squared is equal to r squared. We know that, and we should be able to deduce that. The equation of a tangent to a given circle, we know that for us, if we are given a center and a point on the circumference, we know that the gradient of the radius times the gradient of the tangent, we get -1 because our tangent is always perpendicular to the radius. Now, we should be knowing our properties of triangles. We know that the exterior angle of a triangle is equal to the sum of the two opposite interior angles, and we can use that to get our angles. Also, our triangles, we know that our triangles, we have three different types of triangles. We have a scalene triangle where all the different sides are different lengths. We have an isosceles triangle where a pair of adjacent sides are equal in length. The two opposite interior angles are equal in length, equal in size, sorry. The sides are equal in length, the angles are equal in size. And then we also know that our equilateral triangle where all the sides are equal in length and also all the interior angles are equal in size. Then we have a special type of a triangle, which is a right angled triangle, which is a special type of a scalene triangle, and we should be able to work with that using analytical geometry means, which is we use our gradients, we use the length of the sides, we also use our sizes of angles to help us solve problems involving those. Now, in our circles, we should be able to use the method of completing the square to get the equation of the circle, depending on how it is given. Sometimes we should use our midpoint if we are given the diameter to get the equation of the circle. And then we will also talk about circles that touch each other, intersect, a line that intersects a circle. All those things you should be able to work with them. So here I'll just describe the type of circles that we have. If two circles have different radii, they can intersect externally if the distance between the two centers is equal to the sum of the two radii for the circles, or they can also touch internally where one circle is touching only one side of the other circle. There, the distance between the two centers is equal to the radius of the bigger circle minus the radius of the smaller circle. There, we get our distance. And then, if they intersect at two different points, you will realize that the distance is between the bigger radius minus the smaller radius, and the bigger radius plus that one. The distance between the centers should be in between those two lengths. And then if they do not intersect, the distance between the two circles will be, the distance between the two centers will be bigger than the sum of the two radii. And then also you will realize that circles that do not intersect, sometimes it's a circle that is inscribed inside another circle like that. You will find the radius of the smallest, the distance is less than the radius of the bigger circle minus the radius of the other circle there. Now, please, analytical geometry is another 40 marks. We should not easily lose marks. Please, let's read and understand the questions, interpret them, and we answer accordingly. This is the formula that we normally use for our analytical geometry. and it's given on our formula page, please avoid writing wrong formula. Gradient, it's changing y over changing x, not the other way around. Let's make sure that when we do our substitution, we do it correctly. Otherwise, we will lose marks. Now, we move on now to trigonometry, our main focus for today. Trigonometry, we use our theorem of Pythagoras, reduction formula, identities. We look at special angles. We look at general solutions of our trigonometric equations. We also look at our trigonometric functions, the effect of our A, P, and K. We also look at our compound and double angle identities. We also look at applications of trigonometry to solve 2D and 3D problems, which is our area rule, our sine rule, our cosine rule as well. Now, the formula that we normally use for trigonometry, and that is given in our formula page, is that one. And please let us refer to our formula page, because that is where we sometimes lose marks by writing wrong formula, wrong identities, yet we have them on our formula page. Now, we will start with our cast diagram. We know that in the first quadrant, our x and y are both positive. Hence, all our trig ratios are positive in the first quadrant. 0, 90, 180, 270, and 360. We form our revolution. We move in an anti-clockwise direction. We know the definition of sine. We used opposite over hypotenuse. Again, because we are now in the Cartesian plane, we use our coordinates. In the first quadrant, our x is positive, so the opposite is our y value there, the distance from the x-axis to that point, it will be y units. The distance from the origin to that point x will also be x. That's our adjacent. That's our opposite to this angle theta. That one is our adjacent. Hence, we are able to write our trig functions as in terms of x, y, and r. Second quadrant, it's the same thing, but in the second quadrant, we know that our x is now negative and our y is still positive. Hence, sine is going to be positive because it's y over r. Our tan is negative because it's y over negative x. Third quadrant, both our x and y are negative. Hence, when we do reductions, our sine is negative and our cos is negative. Our tan becomes positive because we are having a negative divided by a negative, which gives us a positive. In the fourth quadrant, we know that our x is going to be positive and our y is going to be negative. That is why sine and tan are going to be negative in the fourth quadrant, while cos is positive. Now, our reduction rules, we know this and we should be able to recall them because these are not given in our formula page, so we should be knowing them by heart, and we should be able to use our reduction rules to simplify and to prove our identities. In most cases, you will find sometimes we are given angles that are above 360 degrees. What I'll encourage, you subtract 360 until you get an angle which is less than 360, then you are able to apply your reduction rules. Negative angles, I know we are taught differently. We have to take out a negative sum. We'd say you can add 360 so that you work with positive angles. Then you are able to manipulate it from there. Now, we know that our identities cos squared plus sine squared is equal to 1, and we should be able to manipulate this so that we work with whatever we want to work. Now, there is our first question. You are given point P with coordinates -7 and 4, and you are supposed to calculate the length of OP. Now, second quadrant. And we know that our angle, it's POR is equal to theta there. The length of OP, we are going to use our theorem of Pythagoras, and we will get it as OP will be given by the square root of our x value, which is -7, we square that, plus our y value, we square it, then we're able to get that one as square root of 65. You get your 2 marks. Tan theta, we know that our tan theta is given by our y over x, and that should give us our answer. We've calculated 5.11. Tan theta, it's going to be given by our y, which is 4 over our x, which is -7. We get our mark there. Cos theta minus 180. If you check on our reductions, it's always an angle minus, an angle plus. So I would encourage you, it depends on how you were taught, but I would say for me, you add 360 there so that this becomes cos theta plus 180 degrees. And I know that I know how to reduce cos 180 plus theta. This is in the third quadrant, and in the third quadrant cos is negative. I'll get negative cos theta, and that should give me cos -7 over square root of 65, and that should give me my answer as 7 over 65. We get our marks there. Now we move on to the next one. I would want us to attempt that one. I will give you 8 minutes to do question 6. 8 minutes. We attempt question 6. Okay, welcome back. I hope you had a good time doing that question. Now, you see that it's sine 10 over cos 440 plus tan 360 minus theta times sine 2 theta without using a calculator. Now, if you check sine 10 degrees, it's in the first quadrant. We are able to reduce that one. Cos 440, it's more than 360 degrees. So what we will do, we will subtract 360 from 440, and that should give us cos 360 plus 80 degrees. This one, sine 10 cos 360 plus 80 degrees plus tan 360 minus theta. We know that this should give us our answer as negative tan theta times sine 2 theta. It's 2 sine theta cos theta, and then this will give us sine 10 degrees over cos 80 degrees. But you are aware that sine 10 degrees can be written as cos 80 degrees. And then from there on, we are able to simplify our answer. And then we should get, in place of tan theta, we know that tan theta is an identity. We can write it as sine theta over cos theta. This cos theta and that cos theta will cancel out, and then we'll get our answer as 1 minus 2 sine squared theta. And from our identity sine squared theta plus, we are able to see that 1 minus 2 sine squared theta, it's an identity on its own. And which identity looks like that one? It's the identity for cos 2 theta. Then we get our answer there as such. So our mark allocation, you substitute the identity, you reduce tan. That one you get our cos 80, and from there on we substitute sine, we get 1 minus, and then for our cos 2 theta, we get our 6 marks there. We move on to the next one. Now, if you check this one, we are going to expand using our compound angle identity. Sine A plus B, we know the identity to use. It's sine A cos B plus cos A sine B. So you will realize our A will be 60 and our B will be 2x. For the minus, we know that if it's a minus, for sine it's also a minus there. So we are going to substitute, and we will get sine 60 degrees cos 2x plus our cos 60 degrees sine 2x plus sine 60 degrees cos 2x minus cos 60 degrees sine 2x. You will realize that I have cos 60 degrees sine 2x, and that side I have minus. This will give us 0. So now I'm left with 2 sine 60 degrees cos 2x. Now, what is the sine of 60 degrees? it's a special angle. We know that this will give us 2. Sine 60 degrees is square root 3 over 2. It's a special angle, cos 2x, and this will give us our answer as square root of 3 cos 2x, because that 2 and that 2 will give us 1, and we are able to do that. But now remember, we've only worked with the left hand side. We know that our left hand side is equal to our right hand side. So in other words, we are able to see that square root 2 cos 2x is equal to k cos 2x. It says calculate the value of k. Comparing the two equations, we are able to see that our k is equal to the square root of 3 there. Square root of 3 cos 2x is equal to k cos 2x. Therefore, our k is equal to square root of 3. Now, so we will get our marks for the simplification there. We move on to the next one. If cos x is equal to square root t, without using a calculator, determine the value of tan 360 sine 60 plus cos plus 2x plus, that is what we are given on our, that is what we are given there. But we know that we have simplified this one, so I can write it as tan 60 degrees. In place of this whole expansion, I can write k cos 2x. Now, we have to find this in terms of t. But I know that this is tan 60 degrees. My k, we have found it as square root of 3 cos 2x. Now, what do I know? Tan 60 degrees is a special angle that I can write as square root 3, and I also have square root 3 cos 2x, like that. I know that this can be written as square root 3 times square root 3 will give us 3 cos 2x, but we are given that our cos 2x it's an identity that we can write as 2 cos squared x minus 1, and then from there on we are able to substitute. Where there is cos, we'll substitute with square root of t, and that will give us our answer as 60 minus 3 there. So these are the kind of questions that we should expect using our compound and our double angle identities, as well as using our special angles. Show that this is that, and also on our simplification. We shall now move on to trigonometric equations. I know we have been taught different methods to solve trigonometry equations. I will use the one for locating our quadrants. We know that if sine is negative, I know that sine is negative in the third and fourth quadrant. So it means I will get my reference angle as 30 degrees. Then I'll find my solution in quadrant 3 as 180 plus 30 degrees, which will give me 210 degrees plus k times 360. And also in the fourth quadrant, I will get 360 minus my reference angle, which will give me 330 degrees plus k times 360, where k is an element of integers. Please, we shouldn't leave that one out. It should always come immediately here, k element of z. It should be there. It always has a mark. Now, it goes with 360 k element of integers. So that is the first method we can use. You get your reference angle, you identify the quadrant where you are finding the solution, and then we can also use the graphical method. Now, how does the graphical method work? I know that if I'm given that my sine theta is negative, if I draw a straight line like that, I want to find the points where the graph intersects the straight line. The red line intersects the dotted line for my graph. Using my negative 0,5 as an example, but remember this graph starts at negative infinity and it continues. I've just shown from 0 to 360 so that we can have a sense of what is happening. So in a way, we want to locate all those points where the red line is going to be intersecting the graph of sine, which is wavy like that. So we want to get all those points. So here I've only indicated the two between 180 and 360 degrees. It intersects twice. And you are aware that these are the solutions that we found on the first graph as our 210 plus k times 360 as well as 330 times k times 360. So if we want to find solutions in the specific intervals, we will substitute our integers -2, -1, 0, 1, 2, depending on the interval that we are given. And we are just substituting We get our solution as that. 5.42, we are expected to determine the x values of the interval x from 0 to 360 degrees, for which f of x will have a minimum. This is linked to our trigonometric functions, where we are looking at the transformations. You will realize that we have said our f of x reduces to sine x plus 10 degrees. You will remember that the graph of sine x has a minimum at 270 degrees and -1. If you check x plus 10, what are we doing? We are shifting the graph 10 degrees to the left because we are having a plus. So if the minimum here is 270, it means our minimum becomes 260 degrees because we have shifted it 10 degrees to the left. So that will be our answer for that one. So it's graph interpretation, and we work with our functions to get what we need to get. Now, I will give you time to answer that one. I'll give you 5 minutes to answer activity 4. Five minutes, we answer activity 4. Welcome back. I hope you have managed to finish the solution. Let's go straight into the solution. We are given sine x cos x plus sine x is equal to, I will not write equal to, I'll say minus. I will take everything to the left hand side. 3 cos squared x minus 3 cos x equal to 0, like that. Now, I can see that I have a common factor. For the first bracket, my common factor is going to be sine x. If I factor out sine x, I will remain with cos x plus 1 minus, I can see that I have 3 cos x, I have 3 cos x here. I can factor out negative 3 cos x. I will remain with cos x. And because I have a negative here, this becomes a plus 1 is equal to 0. This is our factorization by grouping. And we see the importance of factorization even in paper 2. So this becomes my common factor is cos x plus 1. Then I have sine x minus 3 cos x is equal to 0. I know that my cos x plus 1 is equal to 0, or my sine x minus 3 cos x is equal to 0. Now from there on, I'll get my cos x is equal to negative 1, or I will get my sine x is equal to 3 cos x. I divide both sides by cos. I will then have this as tan x is equal to 3. From there on, I'm able to finish up my solution. I'm able to find my reference angle. Then cos is negative in the second quadrant as well as the third quadrant. So I'm able to get my solution as that. Now, our mark allocation, standard form, vectors, we get our both equations, 180, and then we get our 71,57, k element of integers, 180 plus, and then we also have that one. So we will have our 6 marks. Our 7th mark was for factorization, like that. Then we get our solution as such. So we shouldn't lose these marks. We should be able to get them. Interesting ones. Also, you should also be able to solve the ones. You can see that this one just required a factorization, but it has a tan in it because we have to convert. Where you are having sine x is equal to 3 cos x, you convert that one to tan so that you are able to get a solution. In some instances, where you are having cos and sine, you have to substitute either cos so that the whole equation is in terms of cos, and then we can factorize. It becomes quadratic. We factorize and get our 2 solutions. Now, we move on now. Also, we have equations that require us to use our co-functions. For example, if you are given that cos 2x is equal to sine x plus 10 degrees. So you must change your functions so that they are in the same trig function. Either you change them to sine or you change them to cos. It will be easier. Cos 2x, I can write this as sine 90 minus 2x is equal to sine x plus 10. From there on, you make one your reference angle, and then you move on and solve for your x there. So these are the kind of trig equations that we can find in our exam. We shall move on now to our trigonometric functions. Some of the aspects of trigonometric functions, we have looked at them. Our amplitude. In most cases, when a graph is sketched for us, we might have to determine our amplitude. We might be asked to determine the values of Q if it's a vertical shift, or if it's a period shift, we have to find the value of K. But we know that for our functions, the period for the sine function is 360 degrees. For our cos function, it's 360 degrees, and for our tan function, the period is 180 degrees. Just to give us a way of how we get our period, if we are given y is equal to sine 2x, to get the period for the new function, it becomes 180. It is the period for the original sine graph. We divide it by the coefficient of x here, and we will get it as 180 degrees. And then for y is equal to cos 3x, our period will be 120 degrees, 360 divided by 3. For our tan function, the period becomes 45 degrees if you are given y is equal to tan x. Now, you may be given functions that have mixed shifts. For example, if you are given 2 sine half x, you are able to see that our amplitude changes and the period also changes. So you will find on the original graph of sine, our maximum is at 90 and 1. For this, if it's 2 sine x, you'll find your maximum becomes 90 and 2. So our coefficient there, our A, affects our amplitude, our half affects our period, which is the coefficient of x, and you will find that you will get an answer like 720 degrees for the period, and the amplitude is doubled. We get our amplitude as 2. Now, horizontal shifts, we know that from our normal functions, we have done this one where we had sine x plus 10 degrees. You realized that when we wanted to find the minimum for the new function, it was shifted 10 degrees to the left because of that plus 10. The minimum on the original function was 270 degrees and negative 1. So the minimum on this one becomes 260 degrees and negative 1. So we should be able to relate what we do in paper 1 with what we do in paper 2 for our trigonometric functions. So plus p shifts the graph to the left, minus p shifts the graph to the right. We should be able to see that one. And we know that for our sine x plus 30 degrees, our graph shifts 30 degrees to the left. Sine x minus 30, our graph shifts 30 degrees to the right, and we should be able to identify that on our questions. Now, we are given the two sketches of g of x and f of x. We are expected to determine the coordinates of the maximum turning point of g. We are also expected to determine the values of x, where f is strictly increasing. In the given interval, we are supposed to determine the values of q and b, and then we are supposed to use the graphs to determine the values of x, for which 2 cos x sin x minus sin 3x is greater than or equal to 0 there. That's our 6.4. Because of time, we are going to answer these questions together. I will not give you a chance to do them alone, but I hope as I was reading them, you were able also to look at the answers. Let's look at 6.1. We are supposed to write down the coordinates of the maximum turning point of G. You are able to see that our maximum turning point is that one. Our x value is 30. Our y value, we are reading it there, it's a 2. We are done. One mark. We move on to the next one. The values of x where f is strictly increasing. Calculus, strictly increasing, strictly decreasing, the relationship. When we say a function is strictly increasing, we are looking at where as our x values are increasing, our y values should also increase from left to right. Yesterday we used an example of a truck. Where is it moving up? Where is it moving down? You will realize that our graph is moving up between our negative 60 degrees up to there. Remember, this becomes a turning point. It starts to decrease now. Ne? It's strictly increasing between negative 60 degrees and 0 degrees. Now, the values of Q and B, our Q is negative half. Remember, the graph of cos would have a maximum at 0 and positive 1. This one has a maximum at 0 and you can see that it's around half there. Which means we have our graph shifted some half a unit down, and our value of E, we are looking at the period. How many complete cycles do we have there? We will see that our B is equal to 3. If you look at our graph, negative 60 to 60 degrees, we have a complete cycle. So it means the period for this one is 120. So to get the value, you can say your 360 degrees divided by our 120 degrees. That will give us the value of our B. Or the other way around, we say 360 degrees divided by B is equal to 120 degrees. Still, we will get our B as 3. We are supposed to solve now the graph of 2 sine cos sine x cos sine 3x. If there was a typing error in the question, this should be 2 cos x sine 3x, like that, so that we are able to take out our common factor there, and then you are able to see that you are working with your f of x and your g of x, and that will help us get our solution where f of x times g of x is greater than or equal to 0. We are looking at the functions the same as we did in paper 1. We are looking at the region where both f of x and g of x, when we multiply the two functions, are getting a positive. If you check between negative 60 and 0, our g of x is negative and our f of x is positive. Positive times negative gives us a negative, so it can't be there. We want to find where we are getting a positive. From 0 to 60 degrees, our g of x is positive and our f of x is also positive. Positive times positive, so this will give us from 0 to 60. From 60 to 120 again, our g of x is negative and our f of x is also negative. Negative times negative will give us a positive, so we are taking that one. So our answer becomes, it's from 0 to 120, where when you multiply f of x by g of x, you are going to get a positive using those functions. Now, when We're going to look at our trigonometry in 2D and 3D problems. There, please redraw the triangles. You fill in possible missing data. You identify and redraw triangles where you want to get something, where the most are found, and then you start with the triangle with the most factors. You identify the common side between the most, which has more information, and the one where you need to get a missing value somewhere. And we are allowed to use our trigonometric ratios from our right-angled triangles that we did in grade 10. We know that sine is opposite over hypotenuse, cos is adjacent over hypotenuse. So we should be able to solve our 2D and 3D problems. We remember that. So our cosine, sine, and area rules, we remember them. Please also, you must know how to derive the sine rule, the cosine rule, as well as the area rule. Look at the derivation because it's examinable as well. Now, when do we use the sine rule? In most cases, when we are given two sides and a non-included angle, or we are given more than one angle and a side. When we are given two angles and a side. Cosine rule, we are given two sides and an included angle, or when we are given three sides. Area rule, we use it when we are given two sides and an included angle. Let us quickly look at that one to see if we can solve that problem. We are given a landscape artist plans to plant flowers within two concentric circles around a vertical light pole. We are aware of this one. We have seen these somewhere. Now R is a point in the inner circle, and we are able to see that Q and S lie in the horizontal plane. RS is a pipe used for the irrigation system in the garden. The radius of the inner circle is given by R, small r units. The radius of the outer circle is given by QS. You are able to see it from the diagram. The angle of elevation, angle of depression, those are the other things that we should always look at. And how do we work with them? From S to P, elevation, we are looking up. Depression, looking down. RQS is 2x. That's information that is given on the diagram. PQ is equal to square root of 3r. Show that QS is equal to 3r. I will do this one with you. Let's move. Now, we have to show that QS is equal to 3r. Remember, we said it always helps to redraw the triangle. If you check, for us to get QS, we are going to look at triangle PQS. Redraw that triangle. We will get that. This is our P, this is our Q, and that one is our S. This angle is 90 degrees from the diagram, and this angle is 30 degrees. Now, I want to find QS. What am I given? I'm given my PQ as square root of 3r, and my QS I'm not given, but I can use my, if I check my PQ is opposite that one. My QS is adjacent to the angle. Which trigonometric ratio is going to help me get that one? I can use tan. If this angle is 90, this one is 30, this one I know that is 60 degrees. So it's up to me whether I'm going to use this one, my QS is adjacent, or I use that one where my QS, if I use 60 degrees, my QS is opposite. And here are the alternative solutions. If I use tan 30, which is opposite, which is my PQ, tan 30 degrees becomes PQ over QS, then I'm able to solve. That will give me QS as square root 3r over tan 30 degrees. Tan 30 degrees, it's 1 over square root 3, and then I'm able to get my solution as 3r there. I'll get my 3 marks. Or I use tan 60, the opposite is QS over 3r, and I know that tan 60 is square root 3, and then I multiply square root 3 by square root 3r, I will get my QS as that. So use of my trig ratios, special angle, then I get my answer. We move on to the next one. We want to determine in terms of R the area of the flower garden. Now, if you look at that garden, we are told that these are circular like that. So I'm having 2 circles. I want to find that area that I have shaded. The center is common. I know that from my Q to S, the radius here is big R. And then I know that from this one to that one, my radius is small r. So to get the area that is shaded there, it is the area of bigger circle minus area of smaller circle. So the area of a circle, we know that it's given by pi r squared minus the area of the smaller circle, which is pi r squared. Pi is common, so I can give my answer as pi r minus. But remember now, what is the radius of the bigger circle? We just calculated it and we found it as QS. And the radius of the smaller circle is given by small letter r there. Then it means for my pi r squared there, I'll substitute 3r, I square that, minus pi, small letter r squared, and I will get my answer as 8 pi r squared, because that one squared will give me 9 pi r squared minus my pi r squared. I will get my answer as that. So please, we did measurements, so we need to also go back the areas and the volumes of our basic shapes, the perimeters. We should be able to know them because they can be asked here. We move on to the next one. We are supposed to show that RS is given by that. So to get RS, redraw the triangle that you are going to work with. So I'm going to work with triangle RQS. I will redraw the triangle so that it's easier for me to see what's happening. I want to find this RS. I'm given that angle as 2x. That's my Q. That's my R, and that's my S. Now, I've calculated my QS. I found it as 3R. I've calculated my QR. I'm given my QR as small letter r. I want RS. If I look at my diagram, I'm having QR and QS and an included angle, and the side that I want is opposite that angle, which makes my life easy. I'm going to use my cosine rule. That's how you deduce. So from there on, I'll use my cosine rule, substitute, and I'll be able to show that one. 7.4, we are given that R is 10 meters and X is 56 degrees. We are supposed to calculate RS. We are already given. Even if you fail to do 7.3, 7.4, please get those 2 marks because you are already given the formula. All you need to do is substitute and get those 2 marks. Let's not let the marks slide, and then we'll get our answer as 34,996 rounded off to 2 decimal places. We get 35 meters. We move on now. Let's look at the common errors that we make. Amplitude is a magnitude. It should not have a negative sign. Even if your A is given as a negative, your amplitude must not be negative. Amplitude and period. Amplitude is a stretch. Our period, you are looking at complete cycles of one graph. How long does it take to complete a revolution for that particular function? And we shouldn't mistake the two. Please let us not make assumptions. If it's not stated, we can't assume it is what is given. Incorrect simplification. When we do our substitutions, let us check if we are simplifying correctly. And we also use correct reduction signs. Please let us use brackets for our reductions. If it's negative tan, put it in brackets. Negative cos, put it in brackets to show that the reduced form is that one. Even if you are multiplying, show it first before you do the multiplication to get a positive. Otherwise, we will lose marks because we are assuming. For 2D and 3D problems, try to redraw the triangles so that you're able to see. Others, when they're redrawing the triangles, they want to stretch so that it looks like what it is. A right angle must be a right angle so that it's easier for you to visualize some of the things that you can see there. And we should, if we are not supposed to use a calculator, let us not use a calculator. We must show the substitution and the use of our special angles and our simplification. Now, Euclidean geometry, I'll just talk about Euclidean geometry because we also have marks there. These are the theorems that we should know their proofs, and we should be knowing them by now. We did this in grade 11, the 5 of them, and in grade 12, we did number 6 and number 7. Please know the wording in your theorem and know the diagrams that are associated with these theorems, the constructions that you should make or the construction statement that you should write for you to prove a theorem. These are the diagrams. Line drawn from center, perpendicular to a chord bisects. You are supposed to prove that our AP is equal to PB. This must come at the end. It shouldn't start. Here, a line drawn from the center of a circle to the midpoint of a chord. You are supposed to prove that our angle P1 and P2 is equal to 90 degrees there. Now, you will see I'm emphasizing that a construction or a construction statement must be given. The angle at the center is equal to 2 times the angle at the circumference. The proof of this theorem, the constructions that you make must be clear. Naming of your angles B1, B2, or C1, C2 and you are supposed to prove that C1 is equal to 2 times B2. How do you do that? You should be able to do it now. And the different versions of the diagrams, we must be able to use those. Now, interesting one. Our opposite angles of a cyclic quad are supplementary. The constructions that we make here are the ones that make us lose or get the marks. If you are supposed to prove that B plus D, your construction is from A to O and from AC to O. You are supposed to prove that if you add these two, you get 180 degrees. Don't make constructions from B and D. You will not be able to prove. Now, then we have our term called theorem. The angle between a tangent and a chord at the point of contact is equal to the angle subtended by the chord in the alternate segment. That's our term chord theorem. We should be able to prove that one. The diagram associated with our proportionality theorem, we are supposed to prove that our AP over our PQ over our PB, that's our PB, the ratio, we should get the same ratio there. And then, if two triangles are equiangular, then we are supposed to prove that the two triangles are similar. We should be able to prove the ratios that AB over DE is equal to our AC over our DF and our BC over our EF. Those should be equal, and then we are able to get those. So, for our Euclidean geometry, all the theorems that we have known, we have learnt, we must know them. The Euclidean geometry that we learned in earlier grades is examinable. And I would say that our proportionality theorem, our similarity theorem, we did those theorems in grade 8 and 9, again in grade 10, but they seem always to be new theorems in grade 12. Because similarity and congruency, we did it in grade 9. But we forget about them. Pythagoras theorem, we know it. Lines, triangles, parallel lines, we know our, and the way we write our reasons always has to be on point. The types of questions, we know the numerical ones, the in terms of x, the proofs, proportion and similarity, we work on one triangle at a time. We look at the given lengths, the given ratios, or the given angles, and then we have our common angles between parallel lines, common height, our triangles, we know all that, and we should revise all these questions. Now, I will not be able to go through that question, but you will do it later on for your practice. To check if you remember those theorems, you can take a photo of it and you work it out. The proof of our angles of a cyclic quad, you should be able to do that proof. Depending on the examiner, it can be 5 or 6 marks, but you should be able to do it. Now, there is the proof. Answering questions that involve our triangles and our circle in terms of x and in terms of y. With that one was numerical. This is our in terms of x and in terms of y questions. Our proportionality theorem and our similarity theorem. These are the kind of questions that you are likely to meet on Monday. Let's practice all of them. We need to practice all of them. We have the proof of our similarity theorem. We should be able to do that proof, and we should be able to use it to answer the questions that are examinable. Such questions, we know how to get their solutions, and all I can say is, please analyze the information to identify the information that can help you answer the question. And remember, for Euclidean geometry, you always link the statement to the correct reason. You indicate your angles in the diagram. Add information to your diagrams to help you see what's going on. Even in analytical geometry, trigonometry, add information to your diagram. It will help you see what can help you to answer the next question. All statements must be accompanied with reasons. In analytical geometry as well, there are questions which will occur with reasons calculate, with reasons prove that. And you cannot use a follow-up theorem or a follow-up question to answer a previous question. You cannot use an answer for 1.2 to answer 1.1. You must get the answer in 1.1 and then 1.2 moving forward. You can't use a 1.3 answer to answer 1.1. That's not allowed. Just writing irrelevant statements will not earn a candidate any marks, so let us be careful there. Now, when you are proving, please, the order must be correct. Show that the equation is that. It must come at the end. Don't start with the equation that you are given, that you are supposed to prove. Now, use of color is encouraged to help you visualize and see what can help you answer the questions. We must refrain from making assumptions in all the topics. Do not assume. If it's not stated that it's a diameter, you can't assume it's a diameter because it looks like it's passing through the center. I wish you all the best. Let us practice and practice. We will get the results that we want. All the best for Monday, and let us keep on holding on. I thank you. Can I relax? I thank you.